All right, everybody, here we go. Unit 4 review, chemical reactions. Going to go through this pretty quick, but this will help you with the test a lot if you follow through. Take notes. If you take notes, it'll help you a whole lot. And this will get you ready for tomorrow. So we're starting off with writing and translating chemical equations. So going from words to symbols and then symbols back to words. So if I start with the words right here, I read chlorine gas added to calcium bromide produces bromine and calcium chloride. So you see I've already circled and underlined some keywords. First I got to see what elements I have. So I just go word by word. Each word is going to be a symbol, right? So I have chlorine gas, Cl2. I put the 2 there because it's one of those 7 diatomic elements that you listed that when by itself always has to have a 2. You should have that list in your notebook, but chlorine is one of those. So Cl2 plus, because I got that from the added. Chlorine gas is added to calcium bromide. So I have CaBr2 because I had to crisscross because calcium's charge is +2. Bromine's charge is -1. Crisscross, end up with CaBr2. Produces aligns with my arrow right here. Bromine is Br2. It's another one of those 7 elements that has to have the 2 on there. So Br2 plus calcium chloride right here, CaCl2 again, because calcium's charge is 2 plus, chlorine's charge is 1 minus. I crisscrossed, end up with CaCl2. You see how every word correlates to a symbol? Chlorine gas, boom. Added, boom. Calcium bromide, boom. Produces, arrow. Bromine, Br2, and plus sign, calcium chloride, CaCl2. So you could also go back from that. Cl2 is chlorine gas, plus is added. CaBr2 is calcium bromide, and you can see how that works. So that's a really good example right there of translating this written chemical equation into actual formulas. Got another one right here. Sulfur, that's my S. It is not one of those 7 diatomic elements, so I don't need to put a 2. So S can be by itself. Sulfur reacts with, that's where I get my plus sign. It's from the reacts with, that is the plus sign. It's supposed to be a plus sign. There we go. Oxygen, my oxygen, O2. It has to have the 2. To produce is my arrow. A blue flame, we aren't concerned about the blue flame part. Of sulfur dioxide. So sulfur dioxide, you can see that that's a covalent compound because it uses a prefix. So sulfur plus oxygen with the 2 produces sulfur, and then dioxide means 2 O's. So sulfur dioxide is going to be SO2. So that is sulfur reacting with oxygen to produce that blue flame of sulfur dioxide. You can see how you could go in reverse. SO2 is sulfur dioxide, O2 is oxygen, and S is sulfur. And our arrow produce plus sign is reacts with or added to or and. Okay, just in terms of writing out formulas that include polyatomic ions, that's something a lot of us still struggle with. We have that polyatomic ion list. We just need to make sure we reference it. Here, if I gave you copper 2 nitrate, remember the 2. What does that refer to? That refers to the charge of the copper. So that means copper's charge is 2 plus. That's what that 2 refers to. And then nitrate. We know nitrate's charge. First off, nitrate is NO3. You'll see that in your notebook. And nitrate's charge is -1. Therefore, we would crisscross. We would bring this -1 down to the copper. We'd bring this +2 over to the nitrate. Got to put the nitrate in parentheses so the entire thing stays together. So you end up with copper nitrate. And we put this in parentheses because nitrate is NO3. The NO3 can never ever break apart. That's going to be together forever and ever and ever and ever and ever. It will never break apart. Copper nitrate. Now, to clarify, a difference between nitrate and nitride, like if you saw copper nitride, that would just be CuN, like that. CuN, or anything like that. That would be copper nitride, not copper nitrate. Nitrate is NO3. This NO3 is a polyatomic ion, so it will stay together forever and ever and ever. Nitride, that'd just be referring to nitrogen by itself. So I just wanted to clarify that. So if you had like nitrogen dioxide, it'd be NO2. Or if you had like copper nitride, I already wrote that up here. So this is just a quick recap on translating equations. What I would do is I'd go back and I'd make sure that I have this and all of this written down so you can compare. This is nitrate, this is nitride. Copper 2 nitrate, it's going to look like this because that 2 represents a 2 plus. Nitrate looks like this, etc., etc. So that's a pretty good start for us. Balancing equation basics. I'm going to go through this real quick. Pause it if you need to. The law of conservation of mass, that excuse me, that is what states matter is not created nor destroyed. That is why we have to balance our equations, because there has to be the same number of atoms on each side of the equation. Why does there have to be the same number of atoms? Because matter cannot be created or destroyed. It is simply rearranged. Cannot be created or destroyed according to the law of conservation of mass. We are always balancing the atoms. We're trying to get the atoms to remain the same, and we do so using coefficients. So if you looked at this simple equation right here, there should be an arrow right there. We have Mg, O, and then Mg and O. We only have one magnesium over here. We have one magnesium over here. Those are atoms we're counting. We have 2 oxygen atoms over here and only 1 oxygen atom over here. So we have to balance it because we know matter is not created or destroyed. So we would just simply put a 2 right there, which would give us 2 oxygens and 2 magnesiums, and then a 2 right here. The focus on this wasn't balancing the equation. The focus is showing you that we are counting atoms. Atom of magnesium, 2 atoms of oxygen, 1 atom of oxygen. That's why we had to even it out using coefficients. Coefficients can change. Subscripts, elements, things like that in the equation will not change. Only the coefficients, which coefficients are these numbers out in front right here, only the coefficients will change. That's it, just the coefficients. And we are counting the atoms. Okay. Actually balancing equations. There's a few practice ones here. That's why this video is going to run just a little bit longer, because we're going to practice these. First, we start off by counting our atoms. We have 1 carbon over there, 1 carbon over here. We have 4 hydrogens here. There we go. 4 hydrogens here. We have 2 hydrogens here. We have 2 oxygens here, and we have 3 oxygens here because you have 1, 2, and then 1 hanging out right here. Always leave hydrogen and oxygen till the end. Balance carbon first. Boom. Already balanced. Don't have to worry about it. Hydrogen, though, we have 4 here and we have 2 here. How can we change that? By putting a 2 right there. That's going to turn our hydrogens to 4. Our hydrogens are now balanced, but it also messed up our oxygens, right? Now we have 2 oxygens and 2 times 1. So we have 4 total oxygens. See how I got that? I got 2 from over here and 2 from over here. Come over here, our carbons are balanced, hydrogens are balanced. We just need to match up our oxygens. We can do that. We have 2. We need to make that 4, so we'll just set a 2 right there, and boom, now we have 4. So there you have a balanced equation. CH4 plus 2O2 produces CO2 plus H2O, and that would be a combustion reaction. Okay, this one's a little more complicated down here. Let's count our atoms. We have 1 magnesium, 3 magnesium. We have our oxygen's a little complicated because we have the O in here, and we're going to times that by 2 because of that subscript. So we have 2 oxygens here, and we have just 1 oxygen over here. We have 2 hydrogens plus 3. We have 5 hydrogen total. And we have over here, we have 2 hydrogens right here, so we only have 2. And then over here we have phosphate. We want to keep this all together, so we're not counting the oxygens in here and we're not separating the P. We have 1 phosphate here, and because of this 2, it's in parentheses, so we have 2 phosphates here. Now this seems really scary, but we're just going to go one by one and see if we can't work this out. So first let's try to work out our magnesium. If we put a 3 right there, cross that off, makes magnesium 3, balances it out. It also changes all of this. I mean, this one gets kind of crazy. So we had 2 oxygens, right? 2 times 3, that's going to be 6. And we had 5 hydrogens. We have 3 right here. Now we have 3 times 2 is 6, plus that is going to be 9. So now we have 9 hydrogens right there. Now we have our magnesiums balanced, but everything else is screwed up. So let's try to balance out our oxygens over here. We would put a 6 right here. That's going to give us 6 oxygen. And it's going to change our hydrogens to 12, just like that. But now we have our oxygens and our magnesiums balanced. Let's balance out our phosphates and see if that fixes anything. Phosphates, I got to put a 2 right here to make our phosphates work out, right? Because we have 1 phosphate here, we have 2 phosphates here. So by putting a 2 here, we now have 2 phosphates over here. And it's going to balance out our phosphates. But wait, it also changes our hydrogens. 2 times 3 hydrogens is 6. 3 times 2 hydrogens is 6, giving us a total of 12. And look at that, voila, I have it correct. 3 magnesiums on each side, 6 oxygens on each side, 12 hydrogens on each side, and 2 phosphates on each side. So the key here, anytime you see one of these, you want to keep that together. Treat it as one element like I did down here. Treat it as one element. So I end up with 3 magnesium hydroxide plus 2 hydrogen phosphate produces 1 magnesium phosphate and 6 H2O or waters. The other thing you'll notice about why that was easy for me is because I went element by element. I went magnesium, then oxygen, then hydrogen, then phosphate. You can go in whatever order. Typically we should leave oxygen till the end, but I just kind of threw it in there. But if you go one element at a time, you will get it balanced, I promise. But take down these example problems in your notebook, and you can use it tomorrow. It'll help you out a lot. We'll do 2 more balancing equations, and then we'll be almost done. Look over here. We have chromium. We have 1 chromium. We have 1 chromium. We have 1 iron. We have 1 iron. 1 iron. We have 2 nitrates, because remember, I'm leaving that together. And over here, we have 3 nitrates. So really, only our nitrates are messed up, so we just need to solve this nitrate problem. If we have 2 here and 3 here, what common denominator do they both go into? That's right, 6. If we put a 2 here, that will turn our 3 nitrates into 6 nitrates. And if we put a 3 here, that will turn our 2 nitrates here into 6 nitrates, so those are balanced. Let's look what else we messed up. We turned this into 2. Over here we turned the iron into 2. But those problems are super easy to fix because now we have 2 irons and 1 iron, so we just need to put a 2 right there. That's going to make that 2. And then we have to put a 2 right here, and that's going to make that chromium 2. So again, if you just go element by element, keep those polyatomic ions together because they never split up. If you go element by element, you will get these correct. Please do these examples. If you're watching this, please write them down. Please have them ready to use tomorrow. I promise it'll help you. So 2 chromiums plus 3 iron nitrates produces 2 irons plus 2 chromium nitrates. Now down here, my last one, another combustion reaction because we're resulting in these carbon dioxide and water. So we have carbon, we have 2. Carbon, we have 1. Hydrogen, we have 2. Oxygen, we have 3. Hydrogen, we have 4. Oxygen, we have 2. We're going to leave oxygen for last. First, let's do our carbon. Simple. Put a 2 right there. Boom. Turn that into 2. Also turn our oxygens into 1, 2, 3, 4, 5. But we're not worried about oxygen right now. Let's change our hydrogens. We have 2 over here and 4 over here, meaning I got to throw a 2 on here. It's going to make our hydrogens 4. It's also going to switch up our oxygens again because now we have 1, 2, 3, 4, 5, 6. So we have 6 oxygens now. You see how I got that? We have 4 from here because 2 times 2 is 4. And we have 2 from here because 2 times 1 is 2. So for a total of 6. So then I just put a 3 right here. That's going to make that 6. And I'm balanced. 1 C2H4 plus 3 O2 produces 2 CO2 plus 2 H2O. Everybody see how I got that? Just one element at a time, and you'll get it. One element at a time. So that's balancing equations. If you need to go back and watch any videos on it, those can be helpful. But these are just some basic examples. I know I went fast, but that's because I'm trying to keep this review video kind of short, and there's a lot of stuff to go over. Types of equations. What I would do right here is pause and write down these examples as I talk about them because I'm going to talk quickly. Combustion. You can recognize combustion because the products are always going to be carbon dioxide and water. 110% of the time, the products will be carbon dioxide and water. We'll go to the next. We'll go to throw the simplest ones first. Synthesis. Synthesis is when you have 2 elements combining to form 1 compound. So you have NaCl2 combining to form 1 compound in NaCl. Decomposition is the opposite. You have 1 compound decomposing into 2 compounds or elements. So decomposition is 1 to 2. Synthesis is 2 to 1. They are the exact opposite of each other. Anytime you have two compounds on one side, you are almost guaranteed to end up with a double replacement. Here we see that we have OH with PB, and then it switches sides, and OH goes with H. Here we have SO4 with H, and it switches sides and goes with PB. So if you have two elements switching, it's going to be double replacement. Down here, we just see the Cl. The Cl is with Li, and then it swaps, and now the Cl is with Na. So anytime you have one element switching, that is going to be single replacement. Each of these examples, very valuable to you. Recommend taking down the examples of combustion, double replacement, synthesis, single replacement, and decomposition. Also, I'm going to pull up a Word doc real quick to show you the pictures. We went through this in the walk around today, gallery walk. These are some pictures that you'd like to see. So this would be like one compound and splitting into two. Therefore, what would it be? One splitting into two. Where is it? Decomposition right there. One splitting into two. This one, we have these elements, and their little circular part of the elements are switching. And so that's a double replacement because two things are switching. Down here, I love this picture. We got this nice, innocent young child eating an apple, and then he eats a chili dog, and then he becomes a large, obese man. That's just showing that you take two things, combine them, and they're going to produce one, so that would be synthesis. And then this would be single replacement because we have this guy by himself, these two together, and then go through the producing part, and suddenly this guy's with the girl and this guy's by himself. So that would be single replacement. But really, keep an eye on these two, decomposition, compound to two, and then double replacement. So we're done with that. This is going to be our last slide. So types of equations, hope you wrote those down. Last slide, quick key review, just in case some of you didn't get to this point in the stations today. Evidence of a chemical reaction. There are three keys. There's a few other ways you can recognize a chemical reaction, but these are the three most important and the three that we'll go over. It can form a precipitate. If you remember from our chemical reaction lab, that's a precipitate is when two like liquids or gases come out and form a solid. So there's it could form a precipitate. Can produce gas. If it produces gas, it could be evidence of a chemical change. Or if there's a color change. If it goes from white to yellow when you mix two things together, that's going to be a chemical change. So precipitate, production of gas, color change. And that's our review. Covers everything that's on the exam. Hope you get a chance to watch this. I know it's kind of long. That's because we were balancing these equations. Hope you wrote down the balanced equations, down the types of equations. They're really going to help you out now and for the midterm. If you have any questions, ask me tomorrow.